All right, going to do some more examples here. I'm just going to choose them as I go through to try to make this flow a little bit faster. I want to try on 352, that's 6.3. Problem number 6, it says match some of these expressions. Well, if I look at 6a, here it takes 4x to the fourth times 3 to the x. My choice here would be to rewrite these as some multiples. So what I'm going to do is use my commutative property of multiplication to bring these two, to switch these two, because it's all multiplying, so I can switch these two around. So I'm going to call this x to the fourth, and this is times x. So here, well, 3 times 4 is 12. Now when I multiply and the bases are the same, now I add the exponents. And of course, this is x to the first if nothing's written here. So this would simply be x to the fifth. So 12x to the fifth. Let me look at 6c. Here it takes 12 times x and then times 4x. Once again, I'm going to use my commutative property to switch these two. Times 4 times x times x. They're all being multiplied here, is the reason I can use that commutative property. This being 48, and same base, multiplying, I can add the exponents. X times x is x squared. So working it like that. Let's find another problem. Number 12 here on this same one. Laura buys a sofa at for $500. So it starts out at 500. She has this credit card. Credit cards are bad. Try not to use them. Pay them off every month so you don't owe this interest. She's going to get an interest of 1.5% per month. Oh, that's nasty. Now, of course, remember, this means her value, the value of what she has to pay is going up each month. So her per month, it's going to be the 100% plus the 1.5%. So this is 101.5%. So our b value, to write it as a decimal, is 1.015. This is going to be our b value. So if we were to write an equation, we have y equals starts at 500. Multiplier here is that 1.015 to the power of x, where x is going to be the years, or no, x is now months. Very bad. X is now each month, and this is our start value of 500. What's the balance after 6 months? Oh, Laura, she should not be doing this. So we simply want to write our equation like this. This is going to be one expensive sofa for Laura to the power of 6. Now, looking in my instruction or in my book here, it tells me the answer, but you should get, using your calculator, it's going to cost her an extra $46.72 above that original 500 after 6 months. So that's that total extra interest. What's her balance going to be after 12 months? Well, we'll put 12 in for the x. In D, it says how much more interest? Well, then we'll go from 6 months to 12 months, and her value, increased value from 6 months, and then we try 12 months, and it says she should go up another 5109. So definitely increasing here. Actually, I think I want to look at B. So here, this is going to be at 500, 1.01 to the 12. Oops, sorry. This is actually C. The B answer is that extra $46.72. That's how much interest she paid. Here in C, we figure this out, and my book tells me it should be 5,900, or no, I'm sorry, $597.81 is what it's going to cost her after 12 months. So here, this difference between these two, it says, in D it asks us, how much did it change now from here to here? So here, that value, now it's costing her an extra $51.09. Remember, this is a 6-month period here. It cost her $46.72. Now to go from 6 to 12, that's another 6 months, but it's costing her $51.09 for that next 6 months. So here's the first 6 months when she first got the sofa. It's brand new for that half a year. Now the second 6 months she owes, she's paying another $51.09 for the second 6 months. Notice it's cheaper for the first 6, but then it increases. But that's because her interest is piling up on her interest. This is why we shouldn't get credit cards. The first 6 months, it only cost her an extra $46.72. But the second 6 months, it's now costing her $51.09. So every time, interest is being piled on top of more interest until that pile of interest is so huge, you go into big debt and you have to, pay the credit card company a lot more than that comfy sofa was worth. So save and pay off the sofa. Save the money up front, only pay $500 for the sofa, and then save all this money in interest. Sit on the floor for 6 months, Laura. Enjoy the saving of your money so that you can have this to have other things like a nice meal, go out on a date or something. Let's try something from the next section here in scientific notation. Section 6.4, over on page 357. Let's look at a problem like number 6. Number 6 is actually on page 358. Here it says there's approximately 5.58 times 10 to the 12th atoms in 1 gram of silver. There's this many atoms in a gram of silver. We want to know how many atoms are there in 3 kilograms. Now remember, a kilogram is 1,000 grams, so that's 3,000 grams. And of course, we want to know how many there are. So what we're going to do is take this number per gram, multiply it by 3,000 grams. Let me grab my calculator here. Multiply these two out. Well, the easiest way here, let me show you how I'm going to multiply this because you might not be able to read my calculator. I'm going to read 5.58 times 10 to the 12th times 3,000. Now, what I'm going to do is I'm going to move these two separately here and multiply these two together using that commutative property times 10 to the 12th. So if I take 5.58 times 3,000, I get that this value right here is 16,740 times 10 to the 12th. This is not in scientific notation, though, because remember, we want this number to be between 1 and 0. So I need 1.6740. If you want, you don't need to have the 0 here, but it shows our accuracy. Times 10 to the, but now what I need is, I need to 1, 2, 3, 4 more zeros on here. So I'm going to add 4 more zeros, which puts this to the 16th atoms in 3 kilograms of silver. So here, this idea of we multiply these, but I needed to change this number to be between 1 and 10. So I just moved the decimal over, but I moved it 4 places. So I needed 4 more zeros. I need these 4 zeros back, really. So I just put them here in the exponential form. Let's try one more problem. I'll try a little bit from number 9. Here we want to multiply a problem of 3.15, oops, sorry, it's 3.5 times 10 to the 4th. We're going to multiply that to 14.8 times 10 to the 5th. I'm going to use this commutative property once again, since it's all multiplication here. I'm going to just switch these two around. It's easier for me to see it that way. 3.5 times 14.8 times 10 to the 4th times 10 to the 5th. So what I have here is, let me multiply 3.5 times 14.8. And I get that this is 51.8 when I multiply these two together, times. Here the base is the same, so I can, and I'm multiplying, so I can add the exponent, so this is 10 to the 9th. But notice, this is not a number between 1 and 5, so I'm going to change this to 5.1 and 10, I'm sorry. I'm going to change this to 5.18 times 10 to the, now I need one more decimal place here, so I'm going to add 1 in here and get it like that. I tried to do that a little bit too fast, but hopefully you can pause and go back and that type of thing to check it out.